Okay, so now let's look at an example where we're finding the probability for in between two values for a normal distribution. So a survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store is normally distributed and is represented by the variable x. A shopper enters the store. Let's find the probability that this shopper will be in the store for between 24 and 54 minutes. So same idea. First step, you want to sketch out what this distribution looks like and to see what the area looks like. So in this case, we know that the mean is 45 minutes and standard deviation is equal to 12 minutes. And so we want to find the probability that someone's in the store for between 24 minutes and 54 minutes. So we're finding the probability in between these two values. So we're finding probability that x is between 24 and 54. Remember, it doesn't matter if you include the equality or not for a normal distribution, but just out of practice, remember between means we're going to include those values. So I've got 24 is less than or equal to x, less than or equal to 54. If you wrote out just 24 is less than x, less than 54 for a normal distribution, that's okay. And so, well, now we have to convert to z. But the problem is we have two values, so we have to do two different z-score calculations. So we know 24, to convert to z, we're going to do 24 minus 45 divided by 12 is less than, now we're converting from x to z, so it's now between z. And then same thing for 54, so 54 minus 45 divided by 12. And so we do those calculations, and we get that z is going to be between negative 1.75 and 0.75. So now to find this probability, so remember when we're finding probability between two values of z, we look up the larger z-score first, and then subtract that value. From that value, we subtract the smaller value. So if we go to our z-score table, and we look up 0.75, our larger value. So go to the second page, there's 0.7, 0.05, and find where that row and column meet. And so in this case, 0.7734. And then we do the same exact thing for our negative 1.75. So we're back on the first page of the z-score table. Negative 1.7 and then 0.05. Same thing, where that row and column meet at is 0.0401. So we have 0.7734 minus 0.0401. And when we do that subtraction, we get our probability that x is between 24 and 54 minutes. And that's equal to 0.7333. So there's a 73 and a third % chance that a shopper is going to be in the store for between 24 and 54 minutes. Now, same scenario, let's find the probability that a shopper will be in the store for more than 39 minutes. So same idea, we've still got the same setup. So we know our mean is still 45. We know standard deviation is still 12 minutes. So more than 39 minutes. So somewhere about here. And we want everything to the right of that value. So probability that x is greater than 39. Since it just says more than, there's no implied inclusiveness here. And so, same idea. We convert from x to z. So if we're changing our letter, we have to do a calculation. In this case, our z-score calculation. So 39 minus 45 divided by 12. So this is the probability that z is strictly greater than negative 0.5. So we go to our table, and we find negative 0.50. So 0.00 is our hundredths digit. Negative 0.5, go all the way across to where that row and column meet. And we get 0.3085. But remember, since we want area to the right, we're actually finding a complement, so it's 1 minus 0.3085. And so we get our probability that x is greater than 39. Or in other words, the probability the shopper will be in the store for more than 39 minutes is 0.6915. Now let's say we have 200 shoppers in the store. Let's find out how many shoppers will we expect to be in the store more than 39 minutes. So we already have the probability that x is greater than 35. We just found that and saw that it's 0.6915. So if we want to find out how many shoppers now, we just multiply this 0.6915 times the 200 shoppers. And so we get 138.3. So about 138 shoppers. Rounding to the nearest person because we don't want parts of a person floating around in the middle of the air.